loudspeaker and I get different sounds. Okay. Okay. So this is some kind of output device. You can say this kind of output device where my output of my system, whatever may be the processing, can be analog processing, digital processing, whatever, is stored. Is not stored, actually it's displayed as a sound or at a light or something. Okay. And sometimes the system output may be used for some actuation. What is actuation? Actuation may be some kind of switching on of the motor, switching on of the alarm, okay, switching on some emergency lights, etc. So it is also used for actuation. For example, my system output may be used to increase the speed of the motor, decrease the speed of motor, or braking. Okay, so that is also called actuation. Okay, so that is another option. We have actuation. Okay, so what all things we are discussed here? We discussed this kind of input parameter which we are measuring from the environment. It may be force, displacement, acceleration, maybe light, sound, whatever. That physical quantity, uh, we let the sensor expose to that physical quantity. Now the sensor takes the input, that parameter, maybe a physical parameter or whatever, chemical or light or heat or whatever sound. Then it gives the electrical output. Then this electrical output or electrical signal with respect to time is going to my system. So the system have a lot of electronic things like transistor, diodes, etc. Basically, the system consists of like amplifiers made of transistors, or like logical decision making thing, like logical gates or whatever. It can be DSP, digital signal processing, whatever. It can be anything. So, but basically in electronics we use basic unit of any digital or analog system is transistor, resistor, diodes, capacitor, inductor, etc. Okay. So after system do some kind of processing, maybe addition, averaging, multiplication, division, or kind of a big algorithm is processed using the system, and the system output is given to be displayed or to be shown to the user. It can be loudspeaker, input is electrical and output is mechanical vibration or sound vibration. It can be a screen where the electrical things are the input and output is some visual thing or a loud, maybe a display CRT in your smartphone as a screen, okay, LCD screen or LED screen, whatever. Or it can be actuation like a motor turn, increasing the speed, decreasing speed, braking, etc. So this is a typical part of the electronic system. So in this thing, we are dealing basically we are focusing on the system part in the whole course. Okay, what is system? How to design a system like amplifier, filter, or some simple gadgets, electronic gadgets, simple sensing system, uh, some kind of light which is automatically on in the night, or some kind of system which gives alarms when something goes wrong, etc. Anything is possible using the electronic system, and the sensor forms an important part to measure the environment parameters. Okay, with those, so we'll complete the system here. In this course, we'll not be dealing much of the sensor, although sensor things you can read on your own. A lot of sensors are available. There are some sound sensors like microphone, which we are using in your smartphone. This is a good question. When I ask in classes, what is the sensor which senses your sound signal and give input to your smartphone, very less people answer because we are using a lot of sensor in our everyday life. We, we forget even the main sensors. And one of the output transducers are loudspeakers, which converts the electrical signal or the process signal from the smartphone to the output environment as a sound waves. Okay, and there are different sensors like humidity sensors, temperature sensors like called thermistors. Okay, so we'll discuss some of the sensors as we discuss transistors, and others this you can easily read about them in the internet. There are a lot of these days they're coming in cheap also, very cheap. Okay, so you can learn about. Okay, so uh, so right now I just want to give a small case study. So for example, I'm taking example of a line follower. I don't know whether you heard about line follower robot, line follower robot. Some students might have done some projects or some hobbies. Some are interested in hobbies. Industrial hobbyists may be working on this kind of simple robots. But this is called a robot. So why it's called robot? So what is a robot? Uh, Robot is a machine or a system uh, which can it can do something automatically, some kind of it can do some kind of decision making process. And how it is possible? This is possible because of some programs or some softwares, or in general, in simpler sense, there is no need for any program for robot. We can do in analog simple transistors, diodes also. We can make some robots, but their application wise it may be simple, but still as principle they are also robots because they do this kind of decision making. So when you're thinking of robot or systems which are intelligent, or at least some kind of basic intelligence are there in robot, so we should know there is kind of sensing, so processing, and some decision making. The output is that there is some kind of decision they are taken some, so we call it also a decision making thing. Okay, so now our problem is line follow. We have to make the robot follow a line. So I'm drawing a line here. Now you just tell me a idea, how shall I make the robot to follow a line. You just think for some time. I'm drawing a line here and I'm telling my robot should follow the line. Okay, so your robot is placed somewhere here. See, this is your robot. Your robot is placed here. Okay, now it has to follow the line. You have to think some examples of the previous discussion, like sensing, processing, and output. And I also draw two tires also. It is some tires. Okay, so this we expect this to follow this line. So this small case study I'm giving you. So if you tell me some possibilities, how can I make this robot to follow the line? What are the ideas? Okay, so I'll give you 2 minutes. Okay, please think and tell me what are the input. Okay, you can write it. You can write the topic in your notebook and tell me what are the specification. What should be my input? What should be my output? How should the process or system should function so that the robot is intelligent enough to follow the line. I'm not talking about complicated robot, simple robot, which you can design using transistors and some simple sensors and some motors. Okay? So you should tell your answer based on a previous last 5 minutes discussion. Okay, any electronic system need an input which is sensed by a sensor. The sensor gives the electrical quantity of equivalent to that in measured parameter to the system or a circuit process using some analog or digital processing and give some output. It is also electrical signal, and this electrical signal has to be displayed or given to the user, or has to be used for actuation like controlling the motor, stopping, braking, speeding up, etc. So you have to think in terms of that. What kind of sensor you should use, what kind of processing you should do, and output, how you want the output, and how it is possible. Okay, take 5 minutes. I give you 5 minutes. You should write it down, and then ask you some questions so that you can tell me what should be the functionality, desired things in the robot. Okay. Yes, I have some messages in the chat. Kanaya Pandey is saying electronic system run on a principle of input as a sensor, processing by the system, and output as indicator. Yeah. So we have input, processing, or yeah, system, and output. So these are the main constituents of a any system. It can be electronic, mechanical, hydraulic, whatever. Okay. So I just want to think about the present problem, line follower robot, and come up with some ideas for input, processing, and output. Okay. So I'll give you right now there are 4 minutes, 3 to 4 minutes. Yeah, we should use sensor. You should tell what, like Rajnish has written said we can use sensor in a robot. No, sensor is there are thousands or hundreds or millions of sensors. You should tell specifically what should the sensor measure. Just telling the sensor is an input is not the solution. You should tell what should the sensor measure, what will be your input, and what will be the sensor measuring, and what will be its output, based on which what kind of uh, processing or decision making has to be done in the system. and what should be my output, and how the output should help me to solve my problem. Okay. Am I audible?
Yes, sir.
Hello, students.
Yes, sir.
Okay. Okay. So, uh, so, so yeah. say one. I'll give one example. I think I got some comments. Let's see what are the comments. Okay, so first comment. Kanaya Pandit is saying here in robot we can use transistor as a switch for monitoring, directing the path, motor and diode as control for speed. Yeah, as we are top level we can say this is working. Yeah, because yeah, we can say transfer switch. Yes, definitely. So we have to know how we are going to do it. That is more importantly. But yeah, you're right. In a top level, this is the only thing because ultimately system is designed using transistor. So yes, we have to do it directly. That is implied by I already given you this data. Yes, output is a motor. Yeah, you're right. And controller speed, diode as a controller speed. Yeah, let's see. We can design a magnetic paths so that sensors which has the property of sensing magnetic property so that finally it retraces the path. Okay, that is another idea, magnetic properties to deal with. So I have not told you to retrace your path. I just told you to follow the line. No need for retracing your advanced things we can do, but it depends on application. Here I am not telling you to retrace or something. You have to follow the line. That's it. Path color is an input for sense. Yes, there is another interesting idea. Pradeep Moore. Yeah, we can send the color. I told you it has to line follower. There's a line. So that line should be different from the surrounding lines, so surrounding environment. So line color is simple, very good. And Aniket is saying, or we can also use photodiodes also. Yes, and by placing thermal emitters on the path at certain distances. Here these words are all good. Yeah, you can use it, but you should know how these things are working. So we are not going for complicated things, we are using simple things. We can use Arduino in robots. So yeah, Arduino can be used. We can do any microprocessor, any microcontroller in robot, but we are not talking about any advanced application. We are taking a simple case study of a robot. So everything is possible. All those things you told is right, and I'm not telling these are wrong, but these are like you're just telling this can be used, that can be used. You should have some, like, what kind of sensor have you name, what is its operation, and what it gives this input to the circuit, and what is circuit is doing, and what is the output given by circuit. We can use many radiation sensors. Yeah, we can use infrared sensors when robot is moving on black line. IR, yes. That Satya Singh is, I think he already read about line follower, or he made some project, so he's getting IR rays can be absorbed when robot moves. White paint, it starts reflecting IR rays, so it changes. Yeah, so that is a idea. That's kind of ideas we are trying to discuss, or we are trying to uh, receive from students. Okay. And can I use also drink also for controlling motor we can give torque in one motor for faster. Yes, that is another idea. We have two wheels, then one wheel is turning, that means it's turning. Okay. So yeah, everyone is right. And we'll take 1 point from Satya Singh. We'll use sensor in robot at any special color, light energy based, and design a linear path of that color. So robot everything is possible, right? Right now I'm taking a small example. So, in our robot, I call line follower robot. I love power. Okay. It was just a case study. I given a simple case study, and your thought nicely. Okay. So, we'll take 1 point. How the robot has to sense its environment. I already told you the sensing. We have a white light, white road, or white line. For example, I'm just seeing an example. There's a white line in the black background. Now, how the robot is going to sense this thing? Yeah, one option is if it has two sensors. For example, the robot is like this. Okay, if it has two sensors. Say for example, there are two sensors. This one is placed here, another is placed here. Okay. Now, I'll just briefly explain the working of the sensor. Okay. And for example, we'll take an example such as IR sensor or a simple light sensor. Okay. So one of the basic property in every sensor you will be using one property. That is what I told you to think about. How you are going to measure input. What is the physical parameter, physical property of a sensor? Every sensor works on simple properties. Maybe it is like change of resistance, or it may be a change of or giving some voltage signal based on the input acceleration or a displacement or whatever, or pressure. So this kind of sensor, I call one kind of sensor. I'll tell to you that the IR sensor. That is, it consists of a IR transmitter, IR receiver. Okay. For example, this is a transmitter. I have an IR transmitter. I represent using a simple LED. Okay. So this LED, when powered, when given some power, we call V or voltage, whatever. So it it is sending its transmission. It transmits some radiation. We can say IR radiation, whatever. Now, if I have white surface, white things reflects majority or 90 to 100% of this input radiation. White surface always reflects. So in this specific sensor, I'm using the property of reflection. So white always reflect maximum. So I need to use another receiver. Okay, I use a receiver which you can tell is IR receiver. Okay? And there's a circuit and something, and some circuit is also there and the receiver part. So there are two parts in my circuit. One is the transmitter part, this is transmitter part, and a receiver part. Okay. So what is the transmitter doing? It's always sending the radiations. Whenever it is on, it's always sending radiation. But we should remember, when it comes across a white line or light surface, it directly reflects majority of the radiation, and there's a receiver or receiving sensor or receiver which catches my IR, it is sensitive to IR. So it catches the IR. But when when the IR radiation falls on a dark surface, what happens? When IR radiates dark surface, there is very less. There's a very less reflection, and maximum absorption is there. So this my out receiver or receiver sensor doesn't receive much of the radiation. So if my receiver is receiving some kind of energy, light energy or IR, infrared radiation or heat energy, thermal radiation, I tell I tell that I am on a, or the sensor is near a white surface. Getting? If I'm not getting any kind of radiation or IR radiation or some kind of uh, any kind of radiation, I'll tell this sensor is over a, receiver is over a dark surface. Okay, so using one transmitter and receiver, that combines as a single sensor system. So this thing what we just discussed, I can consider as a complete sensor system. This is a complete sensor system with a transmitter and a receiver. Now I had to place the transmitter receiver in a logical way, intelligent way, so that I can sense uh, whether I am over a white light surface or white surface or a black surface. In a white surface, my receiver is always getting a receiver reception back, and the receiver will be giving me output. What will be output? You give me output equal to one something, right? That means I am over a white surface. I am getting a reflection. That means my sensor or receiver is giving me high output. Okay. Now, if we have a two sensor set, like if each sensor, I have told you this is a complete sensor module. You'll get in the market like sensor modules like this, IR sensor modules. Okay. So this is one IR module where there is a receiver, transmitter and receiver, and the receiver gives high when there is a reception of the radiation. If it is low, there is a black surface and there is no reception. Okay, so this is one sensor module. So if I use two sensor modules on either side of my robot, so what happens? So this is my robot. Okay, so it has two tires. Okay, with two tires, and I am keeping this sensor module I just told you at 2 points. One module is here, another module is here. Okay. Okay, so for example, I'll just modify this thing. I'll just tell you the sensor system is such a place in such a way that for example, my input transmitter is like this. Input transmitter is kept like this. Okay, and receiver is kept like this. Okay, so there are two modules. One module I told you, there are two modules. This is module one, sensor module one. This is sensor module two. Okay. Now, what is the agenda? What is my agenda? What I'm trying to do, I'm trying to follow a white line. Okay. I'm trying to follow a white line. This is a white line. Imagine this is a white line. Okay. This is white line I'm following. Now, what is my idea? Now, whenever my both sensors are not getting any one value or high value, that means I'm not, my sensors are not over a white line. So here I'll just write what is my blue and green. I'll just write for our understanding. Okay. So this green is transmitter. So writing green only. The green point is the transmitter of module 2 and this is of module 1 and blue is of receiver of module 2 R2 and this left I have receiver of Bilwa. Okay. So what happens? This transmitter is always sending radiation. It's always sending radiation. Always sending radiation. Okay. It's always sending radiation. Whenever I have black surface, whenever I have black surface, you should imagine that this is pointing towards the your ground or surface of the table or whatever you're keeping the white line. Okay. So whenever my sensor experience a white line, for example, I have white area coming to sensor 1. What happens when I am coming white area? That means what happens? What is the meaning? My robot has tilted to the right. You can see robot might have tilted to the right, and my sensor may be over the white line. Now, whenever the sensor is over the white line, what happens? What happens? For example, here this is the white position. My sensor 1 module becomes over the white line. So what happens? Now it start to receive. The receiver starts receiving this red thing is a barricade. For example, you can think it's a blockage. Okay. So now the receiver is starting to receive some input, some radiation, IR radiation sent by the transmitter 1. So what is the meaning of that? That means my right wheel has moved or my whole robot has moved over the white line and now it is trying to move the right side or it is trying to move over the white surface and coming out of the white line. Getting? At that times I know what should I do? My right or the left wheel should stop. Now my right wheel should move. Getting? What is the idea? The idea is simple. I have two motors controlling the two wheels. Okay. So I'll tell there is a two motors. I have two motors. Motor 1 controlling the wheel 1 and motor 2 controlling the wheel 2 which is on the right. Okay. So whenever both sensor receiver are not receiving any reflected radiation, that means I assume that I am exactly passing over the white line. So I can move both motor or I can rotate both wheels forward. Okay. So that means my both wheels can move forward. So the robot will move straight line. Any doubts? Is there any doubts? I'll explain one more thing. I have two motors and these two motors are connected to two wheels. Okay. These two motors are connected to two wheels. And whenever my robot has to go straight, my both motor has to go forward or clockwise direction. For example, take an example clockwise direction. So what happens? The robot will move to straight line or clockwise or straight line. Okay. Whenever one of my motor stops, while both are rotating clockwise direction, robot is either going forward or backward. Both are in synchronization. But when one motor stops, what happens? When one motor stops, what happens? The robot is going to turn. Which direction is going to turn? It is going to turn to that direction whose it is going to turn to that direction whose motor has been stopped. If, if my left motor has stopped, the robot will move to left because my right motor is still turning. If my right motor is being stopped, the robot will turn to right because left motor is still rotating. Getting? Okay. So this is simple idea of turning the robot. Whichever motor I keep off or brake, the relative velocity of the two motors is different. So what happens? The robot will slightly turn to that direction whose motor speed is less. This might have experience in a curve, in a bend, when you're traveling in a car or something. When you're turning a curve, left the curve is towards left. Our right wheel has to rotate more faster, and left wheel will be rotating less faster. If you do calculation in physics, this arc subtended by an angle with different radiuses will be different. Something like that. It's simple. It's logic. You can, if you're not understood, you can see, think, and understand. Simple logic. Okay. But my fundamental agenda is whenever my sensor will be over a wide surface, what happens? My receiver of that sensor module will get receive a high value in the output. Okay, that's why I call a sensor module. Usual sensors will be different, but here I'm using a module as a kit which is available in the market, which will directly give me high output when the receiver of that sensor receives a radiation. Okay, and zero if it doesn't receive a radiation. And when the receiver will receive a radiation, whenever it is over a white surface, and when it is over a black surface, it doesn't receive any radiation, so output will be zero. Okay, so I'm just trying to explain a complicated system in simple terms so that you can appreciate how we can design the system using simple transistors and diodes, etc. So this is one case study we are taking. So this is a line follower rod, very simple application, and we only have two motors to control. Okay, so whenever receiver receives high, that means that, what's the meaning? That side sensor is over the white line. That means I'm going outside the white line. If I continue in that same speed or same direction, I go outside the white line. So whenever my left sensor or the module one in shown the figure is over a white surface, that means that I have to stop the motor one or left motor so that I have to turn towards right. Getting? Else I'll be going outside the white line. There are many assumptions I'm using here that my white line is fixed length, width-wise, right? Width-wise fixed length. So then only I can assume these things. Okay. So okay. So I think are you able to follow what I'm trying to say? Anyone has any doubt, they can ask. Okay, no doubts, then fine. So when my both sensor receiver are not getting any value or receiver is not getting high or not getting a radiation, that means my white line is equidistant or center is center towards center is toward line center towards my robot. It is passing in between the two wheels of the motor. Okay, so I don't need to bother anything. I can go straight. Okay, the motor is going straight. Okay, so I'll just uh, draw the how it works. Okay, so for example, this is a right turn and there's a left turn also. Okay, so my motor or my robot is here. Okay, so what happens when there is a left turn? So you know that when there is a left turn, which sensor will receive first sensing? Left sensor, right? I have a left sensor which will come across a white surface first. So what I'll do, whenever my left sensor come across a white line, as the case is in the case here my left sensor is going to come across a white line. So what I do, I should stop my left motor. So what happens when I stop my left motor, my right motor is going to turn the robot towards left side. So what happens now? Now my robot is reaching turn left, and now it is reaching in the straight line. Okay, and as it goes on, then after some time in this direction, my right motor is going to send some white line. That means I have to turn right. Okay, at that time what should I do? I should turn off my right motor and allow my left motor to rotate continuously. Getting? Okay, I'll explain a simple diagram regarding. So this is my chassis. So imagine this is, sorry, imagine this is my chassis of my robot. Okay, okay, there are two tires on the two tires on two sides of the motor. Okay, and here I'm keeping my two sensor modules. Okay, so I'll there's a transmitter, the transmitter, receiver of module 1, and another transmitter or receiver of module 2. And what I have done, I have kept a small separation between these two, small separation between sensor, transmitter and receiver. Okay, so what is my idea? When the transmitter is transmitting something, the receiver is receiving that thing. That means my surface is white, right? Surface equal to white, then only the receiver is receiving. Okay, why? Because I'm assuming this is my road, this is my road. Okay, I'm passing through my road, this is my road, whatever the whatever. Okay, and when my receiver is not receiving something, the transmitter is always transmitting, but the receiver is not receiving something, any radiation. That means the surface is black. Getting? So the main agenda here is whenever my line is exactly in between the two sensor modules, my both sensor will sense that it is walking or it is going through a black line. There is no reflection. So the receiver will not receive any radiation input or sensing. It won't sense any radiation. So it assumes that both sensors are walking or flowing through a dark surface. So you can confidently go forward, like rotate the motors in the forward direction or both the motors in the reverse direction, whatever, based on the application of sense. Okay. Now, how the circuit is working. Now I've just drawn circuit of what is happening. Okay. So usually the transmitter is simple. It looks exactly like an LED. This is a transmitter, IR LED. You'll get IR LED in the market. So it is drawn like this LED. Whenever you power on this LED, you'll get a IR radiation, whatever, and it depends on LED. Okay. Now your receiver is also can be also. I'll just for the time being I'll draw a transistor on the receiver side. Okay. So here my receiver is a transistor kind of thing. It's called a photo transistor. Someone was using the term photo transistor. Yes, it can be photo. It's also drawn like this. This is a photon receiver. Okay. So again, I'll told this is a transmitter. This is a transmitter T. This is a receiver R. Okay. Whenever transmitter is powered on, radiation is starting. Okay. And the receiver is a photo transistor. This is called a photo transistor. Okay. Photo transistor. Photo transistor. What is the function of photo transistor? It is a sensor. Whenever light rays fall on its base, it becomes on. Okay. So ultimately, you should know there's a PN junction, and PN junction requires some energy. When there is some energy, there is a current flow. How this energy is coming? It's coming from radiation or light or IR or whatever. Okay. So this is called phototransfer. Whenever photons receive or falls on its base, the transistor becomes on. Okay. That's it. Okay. So here our assumption is whenever there's a white surface, there is a reflection, and this reflection reaches your phototransistor. Okay. The transmitter receiver is done. Now, if the receiver receiving some radiation in the phototransistor, transistor getting on. So in our application, we have seen when our robot. Okay, so here when I have path towards right, my which sensor is going to receive white line first? Right sensor. Whenever right sensor is going to receive a white line, it should stop, right? So this motor has to stop and this motor has to continue its rotation. Okay. So what I got, whenever my photo transistor output is getting high, that transistor has to stop. You getting? That transistor has to stop its rotation. So now I'm thinking I'm how I'm going to design the circuit. So I'll come up with a circuit like this. So I'll draw my photo transistor. So this is my photo transistor. Okay. So whenever radiation falls on my base, I'm getting on. So what is the idea? When my photo transistor is getting on, my motor on that corresponding side should get off. Getting? Now I think you might have remembered the NOT gate principle. Okay. So what I'll do for making a NOT gate? So now I'm going to design using my some experience. I'm using a 5-volt supply. Okay, and use a resistor. Okay. Now I connect a ground at the base of my photo transistor. Now what I'm going to do? I'm going to connect a motor. I'm just giving a symbolic diagram so that you may understand the working. This is my motor. Okay, and this motor is coupled to motor may be coupled to some wheel. Motor is coupled to wheel. Okay, so that it can turn the wheel. This coupling, whatever. Okay, so understanding what I'm doing. So I just drawn something based on my experience. When I'm getting a high volt, when I getting a reception in the base of my photo transistor, my photo transistor is going to be getting on. Initially, it was not on. If it was not on, I can consider there is no current flow through the transistor. Getting? Initially, it was off. There was no radiation in the base of my photo transistor. It is off. Okay, we should remember it is a sensor. Photo transistor I'm talking about is a special sensor. What is sensing? It is sensing light. What happens when it gets light? When light falls on its base, it becomes on. That means collector and these two terminals, the collector and emitter get shorted. But when there is no light, there it is becoming open circuited. There is no current flow or there's no connection between these two terminals of the transistor. We already discussed transistor three terminal switch. Okay, here I am applying transistor as a switch. Okay, every application we have discussed till now, we have used transistor as switch. But transistor is not only a switch, it is only abstraction. But transistor is many other applications we are not touched it right now. We will be touching soon. But here also I'm using transistor as a switch. So when transistor is not on, you know the 5 volt, the current is passing through. Current is passing. Sorry, the current is passing to the motor to the 5 volt and it is motor is rotating. Okay, so the motor is rotating, the wheel is rotating. But as soon as the transistor receives some radiation on its base, what happens? That circuit is on. That means now I have a new path for the current. Now my current is flowing through the 5 volt resistor to the ground. So what about the motor? The motor is not receiving any current, so motor becomes off. Getting? So what is advantage? Whenever my sensor receives the radiation or light, my motor becomes off. Motor of that side becomes off. So similarly, if I make a circuit in the opposite wheel or right or left wheel, whatever both wheels, I'm designing a complete system which is based on my which is working based on my photo sensor or photo transistor input. Whenever the light is coming to the base, the motor is off. Whenever there is no light in the base, there is motor is running. Getting? Although I am giving you uh, a simple application, although this same circuit is not designed like that, but for all practical understanding, for application understanding, for understanding, I'm explaining in a simple fashion. Okay, so whenever there is no light on the back on the base of the photo transistor, the motor is always rotating. So the robot is straight, going straight, and each part of this robot have same mechanism which is controlling both motors, left motor and right motor. So there is no input on the left and right motor. The robot is going straight. Whenever there is an input on any of the motor, any of the transistor, the motor is going to stop that side motor, and so it is net effect. It will be rotating. So while rotating, it is able to take different turns to left or right. If it is turning right, what happened? The right motor has to stop. If it is turning left, the left motor has to stop, and the right motor has to go and rotate. Okay. So this is the example of actuation. We have sensed the light. By using light sensing, we have understood whether the sensor is over a white line or not, and based on that knowledge, we have actuated. We have actuated the motor working. Okay, we have tried to control the working of a motor using that idea. So this is a simple circuit which only requires two, three things only: two sensor modules, two transistors, two resistors, and two identical motors. Okay, so this is some example of a simple system. Even the current knowledge, with your current knowledge only, you can understand, or even you can make even some circuits, and you can which is household circuits like sensing, and a lot of sensors are available in the market. You need to just search it. Okay, a very low cost. These sensors are costing very 2 to 3 rupees. That is one of the advantage of electronics. All the sensors, resistors, even motors you may get 20 to 30 rupees. DC motor, different kinds of motors are there. Okay, and a lot of mechanical work is also coming, like coupling the motor to the wheels. Okay, you need gears. So these things, if you try it, is very interesting. As same, it will be challenging, and this is the way people go to robotics industry, mechatronics industry. Okay, so these days there are a lot of applications like that. So this starting to understand the circuits is the first thing. Then you should try to make one, you should simulate one. Then you will be slowly exposed to more and more kind of sensors, more and more kind of actuators, relays, gears, and you had to do small kind of troubleshooting, fabrication of some circuits. Okay, so this is something. If you're interested, you can go ahead and you can. So this is only analog. This is I'm using this robot. I'm only using analog parts. But if you want advanced functionalities, you should use some kind of digital processors, memory. You can use a memory. Okay. So this is I'll give some reference to some websites so that you can uh, learn more about this kind of robots and all those things. And one of the main circuits used in robots, whatever the robots you're using, one of the main circuit is H bridge. I think you are aware. I have discussed H bridge in previous classes. What is H bridge? H bridge is a mechanism to rotate the motor in both directions. Here in this motor, you can see we have discussed our motor is rotating only in one direction if there is a current flow. If there is no current flow, my motor is stopping. Okay, there is no chance of changing the speed control also because it is simple system. Now, now if I have some complicated setup, I can have rotate the motor in multiple directions. So that circuit is called H bridge. I think I already discussed some time back. I think there is a motor, and four switches are there. One switch like this, okay, to ground. This is plus 5 volt. Now, when both these switches, I name these switches as S1 and S2. This S1 and S2 is on. You know the current is flowing in which direction? Current be flowing in this direction. That is left to right. So the motor is rotating. Net effect motor rotating, for example, clockwise direction. Okay. Now, if I want the motor to rotate in counterclockwise direction also, what should I do? I should make two more switches. So I make two more switches, S3 and S4. Connect to ground also. Okay. I name them S3 and S4. And again, I connect this also to the 5 volt supply. Okay. Now, if put S1 and S2 off and I on S3 and S4, what happens? My current direction is changed to right to left. This is my current direction right now. So my motor is going to turn in anti-clockwise direction. Okay. So this is called H bridge. Most of the motors or robots which we see, which is wheeled robot we see every day, is using this H bridge circuit. Okay. So there are four switches S1, S2, S3, S4. And who controls the switches? There is a brain, and that brain is called system or a circuit. All these switches are intelligently controlled by circuit. And what is the input to circuit? You have sensors. Sensor signals are input to the circuit, and sensors, they are placed so that they can gather data from the surroundings. So surroundings, they will catch data which is light, sound, whatever, humidity, temperature, and that input to the system, and system or a circuit process that data, and ultimately they they control some switches of our actuation device or motor, and your robot works or a system works efficiently. This is similar. Similar is the case of an industrial system. In power electrical or electrical system or electronic system, you you find in which is mostly in industries, you'll find the same system: sensors and some process or system or circuit, then output device, motor, what generator, whatever. Okay, so this is a complete uh, system which I want to discuss with you, so that whatever we discuss from right now, you can appreciate that this can be used there, it can be this here, amplifier can be used here, etc., etc. Okay, so ultimately we are just touching, completing the whole thing: input, the processing or system or circuit, and the output. Okay, that's a complete system. Okay, so we discuss simple motor control. However, first we need to make an idea how I'm going to control my robot. Should I'm following a right, I'm going to follow a line or something, etc. Fine, you can put your roll number. Any doubts you can ask. Okay, if it is a short, I can. Why Murthyunjay Kumar and okay, fine. Okay. Any doubts?